Well, howdy, physics sleuths and inquisitive souls, and welcome yet again to another lecture of dynamic gravity. So, about a month ago, came across a radical epiphany. And I just kept following this rabbit hole. I just kept digging in this motherfucker, and I wouldn't fuck off. Just to see where it went. And lo and behold, it went to the holy grail of physics, field theory. I know it all. It's official. It's all dunsies. I have done what I set out to do 3.5 years ago. I have conquered all of physics. It's all done. I've conquered all of religion. It's dunsies too. And I've spread the word about the end days. And that's coming. 4.5 more months, baby. Looks like this might be my last episode. Maybe ever. Maybe just for a while. I don't know, we'll see. Maybe God will give me divine inspiration to make more stuff here once again. But in the meantime, it's done. So let us celebrate with just a drinky poo. Just a little bit, you know what I mean? Not too much. We're not going to get like too crazy here. We're just going to go a little bit. We're getting so fucking schizored. It's how you do physics. I have to keep telling people this, man. You got to be fucked up out of your mind on drugs and something, man. You can't be right in the head, bro. If you want to see the truth, you got to be a little twisted. Because reality's a little twisted. That's just the way it be. Nobody wants to fucking listen to me. They all think I'm stupid. Because I don't do what they fucking want me to. Alright. Man. Light 'em if you got 'em, boys. Pour yourself a stiff drink. This is probably going to be one of my longest and most brutal lectures ever. So just calm down. Just chill out. We ain't getting through this fast. It ain't going to happen. It's going to be slow, arduous, and painful. I insist. So, I guess let us begin. The first step. Let's see what the current theory of fields is. And we got here. We ask Google's, the know-it-all, what the fuck is a magnetic field, bro? At its core, a magnetic field is just an invisible field, a force field that surrounds anything magnetic. It's a zone where magnets can pull or push or twist other magnets, moving charges without even touching them. They don't fucking know. They ain't even trying to... They don't fucking know. They have zero fucking clues. Zero fucking clues what a field is. They have no clue at all. Nada. Zero. Yeah, they don't know. They have no clue. But I'm about to explain everything to you. Magnetic field, electric field, gravity field, gravitic field. What's up with that right hand rule, baby? Everything. We're going so deep on this episode. It's going to be biblical. So, let's begin. All right, where do we start here? Nayotanori. The art of eating sushi off of naked women. Procedure. Model is generally expected to lie still. I don't know how this got here. You know, it's almost like there's a sinister part of me in my own brain that's working, doing things that I don't even know about. But I know this. I'd eat some sushi off her. I would. Whatever. General relativity. They have no clue what a field is. They don't know. They just call it space-time. Instead of having a field, they say space-time. And they say, well, it's space and time merged together. And they bend together. But they move. And they're like a bowling ball on a trampoline. They have no fucking clue, bro. They don't know. Dunsies. String theory. No fucking clue. They think it's just little itty-bitty strings vibrating. One string vibrating at different frequencies to make whatever it wants to be on that day, depending on how it feels like vibrating. It's bullshit. They love it, though, because the math is simplistic. As long as there's only, like, I don't know, 11... what was it, like 11 realms, 11 different perspectives, 3D, 11D, yeah, 11 realms. Instead of 3 plus time, it would be like 10 plus time. It's like 11 spatial dimensions. Yeah, that's what it tagged with. So they have no clue. It's all bullshit, man. They don't know. It's all bullshit. It's all bullshit. And they try and hide it with simplistic. But don't you agree that if two things combine, they make one thing? Ergo, string theory must be correct. They have no clue, bro. They're retarded. They ate too many paint chips. They don't know. Quantum mechanics has no fucking clue, bro. No clue. So, well, we know that it's got these fields make these orbitals somehow, because that's where the electron, we find it. They say it's a waveform. That everything's waves of energy. Okay, but what is the energy made of then? What's actually doing the waving? They don't know, bro. They has no fucking clue. Nothing. They got nothing for you. They trash. But their math does work out as long as the electron is in its larger cloud style format. Classical field theory, the OG, yeah, just fields, doing equations with fields. What's a field made of? Ooh, field is a field. Every particle has its own field. Ooh, the particle's a manifestation of that field. Ooh. They have no clue. They don't know what the fuck's going on, bro. They don't fucking know. I know, though. I know. Let's take a look. I just published my 5th paper today. Not today. A couple days ago, technically. Alright. Good old European Journal of Physical Sciences. Gotta love those guys. Literally the only journal that would even listen to me. All the other ones are like, what? You're not a string theory component or a purist, or you're not trying to prove general relativity? Well, then fuck you. You don't get a say. That's what they told me. Think I'm bullshitting? I got the emails to prove it. So, dynamic gravity. My theory of gravity that I curated about 20 years now. About 20 years ago. I first came up with it. And back then, it was much more simplistic, only explaining gravity, not calculating it, like I now do. And I just kept going. And now I know everything. And I'm going to share it with you. And we're going to go by this whole paper, bit by bit, until you understand it all. And it's a doozy. It's not going to be fun, all right? This paper explains totality in regards to how quantum entanglement, spin in general, or in an atom, a right-hand rule, shock waves within the electric field, explains dynamic gravity and finding the smallest bit of matter possible, generated, is currently called a virtual photon. We're going to have to rename everything. I think I warned you guys this about a month ago. We have to have all new terminology to explain everything. And we have positive feedback loop dynamos. Those are going to come in important later. So we begin. Dynamic gravity, the only theory that's perfect. Its math is perfect. And by perfect, I mean 100% perfect. Zero need for correction. On my first paper, it was off a little bit, my math, because I had forgotten in my infinitesimal drunken stupidness to apply my modified formula for G to both black holes that I was calculating. Instead of, I just did it for one black hole and assumed that the other black hole was a constant of a star, typical star. And so that threw my math off a little bit, which was still, it was still very close. It was only like a few orders of magnitude off, where general relativity is like 10 off. So it was still very close, but it wasn't perfect because of that one reason alone. And if you correct that math in my math Excel sheet that I have linked in all of my videos, you can do the math yourself. It's all right there. It's so easy, and you can see it's 100%. Test it out with anything you want. It works out. I've already tried it on everything I could find. Couldn't break it. I tried to break it, couldn't break it. My math works. It is what it is. And DG explains everything. Blah, blah, blah. Dynamic gravity has replaced the irrelevant Big Bang model of the universe, being lambda CDM being the front runner, and the other variant hypothetical rubbish of the gradual universe theory has since replaced. So right, did a whole video on this, replacing the Big Bang. I only threw this in there because the editor, the publisher, wanted me to address that this was inconsistent with the Big Bang theory, and I'm like, you don't get it. I'm so far ahead of you. You're like years behind me on this. But yeah, Big Bang, it's all bullshit. It's not. There's no Big Bang, dude. It's a gradual universe theory. I explained it in my video, if you care that much about it. The universe, we know, was not created going 100% in a millisecond, blah, 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 incompatible, DJ in all ways. The universe came about gradually over about 100 billion years or so. Who knows? I don't know the exact date, how long it was. Who knows how long it takes to calculate this sort of a thing. I haven't even tried, but I know this. The current estimate, the universe is like 15 billion years old. It's so far off. It's laughable. And they're just now finally starting to realize this. I knew this like 4 years ago, 3 years ago. I'm like, yo, dude, this. It's got to be at least double what they're saying. Like 100%, at least double. Probably more like triple or quadruple. It's a lot. It's probably at least 100 billion years old. It's a lot. All right. It is what it is. Recent currently Big Bang model and the dot of time disproving that bad boy because it sucks and it's wrong. But as DG demanded, it has no choice but to classify the term graviton. All right, now we're getting terminology here, boys. Okay. So, in my second paper, I predicted a phenomenon where if you had, say, neutrinos bombarding a particle or something, right? One of the interactions that would come about from that would be as electrons flow through stuff and make the electrons wiggle. Neutrinos would flow through stuff and make the positive core, the nucleus of the atom, jiggle a little bit in regards to the electrons, so vice versa. And what that would do would create a very ultra low photon that, I call a poton because it's coming from the proton. It's not a photon coming from the electron. So there's different. It's not the same. It's different. It is different. So it needs a new name, poton. Okay? And it has different qualities than a regular photon too. But they haven't discovered that yet. All right? So you have neutrinos that will come by and hit stuff, right? And it'll cause the nucleus to jiggle a little bit, which will release radiation from that, kind of like electromagnetic radiation from the electron, only be from the core of the nucleus, positively charged. And so what you'll get is a proton coming out of that, right? And so I said, okay, well, we already know that we have very, very low frequency photons, but they can't measure them. The lowest they can measure is like 1 hertz. Anything below 1 hertz is like, or that's like ultra, extremely low photons. That's like as low as we go. Anything below 1 hertz is now almost like a negative inverse photon, because it takes so long by our arbitrary scale of 1 second. 1 hertz, 1 second, right? And so, yeah. And so I call that a graviton because I theorized it would be possible that it could transfer some gravitational energy through that, being that it is essentially kind of the same of whatever a graviton, the particle of the field being emitted of the up quark, which is the gravitational field as we know it according to dynamic gravity. Okay. Now, I called this ultra low energy wavelength photon a graviton in my second paper because it seemed appropriate at the time to do this. I didn't have any clue about field theory, what it could be at that time, and I didn't want to touch it because I knew that I wasn't able to at that time. But now I can. Now I can get my hands and paws and fingerprints all up on that bad boy. It's mine. Lick that bitch. It's mine. So, what I'm doing is I am reclassifying the terminology. Otherwise, it's going to be a fucking mess. And it's going to be a mess for eternity, for everybody to deal with after me. And I don't want that. I want them to have a nice, clean, concise terminology that neatly fits together so the brain, the human brain, can easily spot patterns as we're meant to do. Okay? So, I am changing that classification of an ultra low energy signature wave photon that's less than 1 hertz to a virtual photon, or virtual poton, and I will call a virtual photon an ultra low energy electromagnetic photon that comes from an electron. That will be now called a virtual photon because it's so sparsely gathered out, it's almost not real, but we know it's there, it's real, it is a thing. We've done experiments, but it's a thing, okay? And now, what we're going to call the graviton is the actual field-carrying particle. What makes the field up, the gravitational field, being emitted from up quarks. Okay? That is what we are now going to refer to as a graviton. So when I say graviton, from now on, what I mean is that very small, minute particle, we're going to go all into it, that is being constantly emitted in all directions from up quarks, that's creating a gravitational field that's attracting stuff to it. All right? And because the electron and the up quark are two completely different fields. So they have two completely different particles, okay? It's not positive, negative particle like you're being taught. This is bullshit. And this is one of the reasons why no one's been able to figure this out. It's an assumption that's erroneous, that leads you in the wrong direction, okay? The true positive and negative field of gravity, like the regular would be from an up quark, and the inverse, the negative form of that, would be an anti-up quark. As a electron would be the normal field particle for that field, and the positron would be the oppositely charged variant of that. Okay, so that's where the charges come into play. The electron and the up quark are not the same charges, but they are attracted to each other because they do disintegrate and annihilate each other. At least their field component particles on those particles. But the actual two particles themselves, as we do know, do not annihilate. Like if you bring an electron and an up quark together, they do not annihilate together and then release two photons. They're completely different integer signatures. They cannot do that, okay? They just get stuck together. Okay? But if an electron and a positron touch, because they are truly a positive and a negative charge variant of the same thing, they cancel out and disintegrate and annihilate into nothingness when they do come to contact. Okay? I have to explain these things to you. So the component that's going to be released from that creates the field around up quarks is the graviton. Okay? The graviton. And the component that releases, that comes out of the electric field, the electrons, is we're going to call an electroton. Okay? Not electron, electroton. Okay? It's kind of like graviton, only electrically based. And the graviton is kind of like the electrical one, only gravitationally based. See how I did the play there? Okay. So, now we got our terminology. We got our virtual photons, which are very low length photons, and we have the actual field components, what's making the field, and that is going to be gravitons from the up quark and electrotons from electrons. Okay? Get used to that. We're going to be going to that quite a lot. Okay? Now, of course, shall we begin? My catchphrase. DG's proposed the exact methodology for entanglement. Now, my last paper, I proposed exactly how entanglement works, but I didn't explain everything. There was one minute piece that was missing that actually explains what's the spinning is going on. It's causing the quantum spin. Okay? I overlooked that. My bad, I'm not perfect. But I made a video about that, about a month ago, explaining that. I do have to do a retcon to that. Alright? And that in that video, I said that the dominant position, that when an electron gets into an orbital, it will, in a conductor anyways, it should be up spin. This is not true. In reality, it could be upspin or downspin, that first electron in the valence shells of conductor, molecules. But according to Hund's rule, all the electrons are going to follow that same architecture. So they're all, the first ones in every orbital is going to be either all up or all down. And then they're going to fill out. And when they fill out, what you're going to have is like a line of conductor atoms, like silver or copper or something like that, right? And so you're going to apply voltage. So you're going to surge a bunch of electrons. They're going to be forced electrically, static electrically, to go down this chain of conducting atoms, okay? And they're going to hop in from orbital to orbital. And then they're going to hop into the same orbital that's, we got an electron that's already up or down, and then they're both going to become entangled, okay? And then the one that's preferred to be kicked out is the upspin electron. Don't know why, but that's the deal. And so what you essentially have is a conductor where all the electrons that are flowing down this bad boy all have the same spin, upspin, okay? And that's going to make your right-hand rule for the magnetic field, okay? So, yep, going off orbital. Okay, so, yep, here we go. Here is a diagram, all right? Kind of like my diagram I had before, yeah. Only now this time, we have the direction of the drift or quantum spin. So we got the nucleus here, right? We have these two electrons. They're going to be sharing the same orbital, all right? Now the nucleus is going to be interacting with these electrons. Okay, this is known. I'm not making this up. This is a known fact. I have it in here somewhere, but it's some fine structure interaction rule or something. I don't know. I forgot, but What it means is that the nucleus is positively charged, and the electrons and their shell around the nucleus are negatively charged. The nucleus is known to spin in regards to the electrons in the shell, okay? And that spinning makes the whole atom have a whole magnetic field that wants to push all the entities that are charged in it a certain direction, as magnetic fields do to charges, okay? These electrons are charged, okay? They are both in the orbital, and they both want to go into each other, all right? So their momentum is canceled out. Now, in this one, this was before I figured out the actual direction of vorticity. The actual direction of vorticity is actually the opposite. It's actually coming back around this way. But their momentum is indeed going and sandwiching them together, okay? So they're sandwiched together in this orbital, and you have the nucleus around it, below it, whatever, spinning, making a magnetic field that's going to affect these two charged electrons, and it's going to make them want to spin a certain direction, depending on the orientation of the nucleus when this happens, okay? Now, usually for the outermost valence electron, I'm going to go on a limb and say that direction is going to be pretty similar, usually the same direction. Rarely not. But it's going to make both these electrons want to spin to the right, okay? Both of them. If there's only one, then the one electron will spin that direction, okay? To the left, however you want to see it, okay? But if there's two, they're going to be stuck together. They're both going to spin the same direction. So they're spinning. They're going into each other with momentum, but they're spinning vorticity apart as the true vorticity for electrons. For positrons, it would be opposite vorticity. They have a different vorticity because it's all reverse. The mechanics are reverse. We're going to get there. This is going to be a fucking doozy of a lecture, okay? Just have a drink, chill out. We're going to get there. Slowly but surely. So, you have these two electrons that are spinning into each other, but they're also spinning this drift, I call it, the other direction, which gives them their spin. Now, when you take these two apart, you can see here's the same thing here, right? They're going into each other, and they're both spinning a certain direction. They're going into each other, and they're both spinning a certain direction. You take them apart, put them side by side where the momentum's going the same direction. What do you have now? Opposite spins. They are going opposite spin directions. Okay? This is what we need to make a magnetic field. We have to have some sort of asymmetry going on in this perfectly symmetrical particle. We have to, or there's no way you can have the preference of the magnetic field wanting to curl the right around this direction, the right-hand rule, instead of the left-hand rule, or just all directions and have it all cancel out. They're all spinning in the same direction. Something is spinning in the same direction to make the right-hand rule. A magnetic field is what the right-hand rule is. It's a magnetic field. It's when you have a bunch of electrons spinning the same direction, their fields are spinning, and now you have the curl of the magnetic field. And now with that curl, you have a magnet where it's like, the field goes out of the North Pole, goes around, it curls around, and then it goes back through. Okay? That's an interesting dynamic too. We're going to get there. Okay? So, just know, excuse me, this is the origins of the magnetic field, is electrons all having the right spin, okay? I explained this detail on my last video, and all the information is pretty much good except for, of course, the Hund's rule part with all the atoms being upspin or downspin when they first get there. Other than that, the rest of it's all good. Okay? Now, okay, so we know when two vortexes collide, they will flatten out and reconnect into smaller vortexes. And those smaller vortexes will have the same spin. They retain that angular momentum when they're formed. Okay? So, one big spinning vortex, if it breaks apart or any of that energy from that spinning vortex is transferred into smaller subsidiary vortexes, those vortexes will have not only the same vorticity, which is the direction this vortex is spinning, which, keep in mind, in reality it should be spinning the opposite direction for an electron. A quark would spin this direction. An up quark or a positron would spin this direction. This diagram would be accurate if these were two up quarks or positrons that were being entangled. But because it is technically electrons in an orbital shell, this vorticity should be going the opposite direction. Okay, just got to really emphasize that. Okay. Now, any vortex that's made from this, though, is going to have the same direction of vorticity and this spin, this drift, this whole thing that's spinning. That angular momentum is also going to get transferred and conserved by any subsidiary or tertiary tori vortexes that are somehow spawned or generated from this vortex. And remember, in dynamic gravity, that's how we get more vortexes, is from the vortexes that are already there. They aggregate and disturb the field when it's strong enough in a way that's good enough, has enough energy dumped into it enough to create another vortex. And now we've replicated the particle. This is how I explained AC electricity. DC is a different beast. AC electricity, when you have a magnet going through wires, that magnetic field is dragging these electrons back and forth, and when it does, it's creating more electrons, and that is where the electricity is coming from. Otherwise, it violates the conservation of energy law. Because think about it, you can literally have like a magnet just going back and forth, an electric, or a coil generating electricity forever. It'll never stop as long as you keep moving. So how is the energy conserved if the electrons that are inside the conductor are just simply shifting and they're never being used up, or there's no more being generated? It's just those ones constantly going back and forth, and that's what's powering your device for eternity. There's no transfer of energy. This is why it's wrong, okay? This is why I made this, to correct this years ago, to explain all of this stuff. But nobody will believe me because they're stupid as fuck. But that's the deal. That's the way it is. So, what I'm getting at is that when you have a vortex that makes other vortexes, it's going to preserve that vortex's vorticity and spin. Okay? Do you want to guess what electrotons and gravotons are? That's right. If you said they are also vortexes, like every other particle in all of dynamic gravity's universe, you're right. Good for you. Have a sip. You earned it. Okay? So, we have a vortex that is somehow spitting out a bunch of smaller vortexes that can serve and have that same vorticity and spin that are going with that. Okay? Now, these smaller vortexes, the electrotons and gravotons, they don't have anything else that they emit. They're too simplistic of a vortex. They're not a perfect vortex in that an up quark or an electron are, and that they are constantly going inward on themselves. Okay? Think of an electroton or a graviton more, not quite the same, but more similar to a photon or a proton. When it is like an electron or a neutrino, but it is a failed vortex, and that it does not perfectly bounce back on itself. Okay? It doesn't cannibalize and go back on itself as a true electron or positron or any true perfect vortex in dynamic gravity does. It is spread out over time, which gives it more of a wavy-like nature to it. Okay? Ergo, the photon. Now, think of the electroton or graviton as a intermediate between the extremity of the perfect vortex of an electron and the complete and utter failure of a vortex of a photon, because it occurred over a time period and didn't go back in on itself quickly like an electron would, creating a new electron from a magnetic field being dragged across it. Okay? So, we know, it's a fact, electrons and up quarks have fields, okay? And I say that's because they're perfect vortexes. We're going to get into why that is. We're going deep on this one. But a photon or an electroton or graviton, because it's a failed vortex, it does not feed back on itself, it is incapable of spitting out any of that energy or making more of its energy in smaller, yet even smaller vortexes that would generate what we call a field around that particle. This explains why electrotons and gravitons are truly the smallest bit of matter possible in the universe. Nothing can be smaller. They are literally the tiny, minute components that make up a field surrounding a real particle. And particles like photons or protons are also incapable of generating a field around them because it's spread out in time, so it can't hit itself, and that hitting itself is what is generating more smaller tertiary or secondary vortexes that are going to shoot out omnidirectionally as it's doing this. Okay? Now, you might be asking, how big are these electrotons or gravitons? Well, we know that a up quark has about 3 or 4 times the energy in it as an electron, as I predicted. And I predicted this is because the vortex of the up quark is spinning faster, which means, according to vortex stretching theory, which is real, I'm not making this up, the faster a vortex spins, the smaller it's going to be and the more stable. Okay? And since dynamic gravity predicts that up quarks are spinning about 3 times faster than the vortex of an electron, makes it more stable and smaller as well. Also because black holes are characteristics. Then the up quark is going to be smaller than an electron. Ergo, the vortices that are generated by the up quark's vortice, theoretically, you would expect to be smaller as well if that vorticity, that energy, is truly conserved and not just the momentum and direction of it, but all of the momentum is conserved. Then you would have gravotons would be a faster spinning vortex than electrotons, just like an up quark is a faster spinning vortex than an electron, which means technically the graviton, the field carrier particle for gravity of the up quark, is going to be the true smallest particle in the entire universe. Nothing can be smaller than that. And you might be asking, okay, how small are we talking about, Sean? Well, I don't know. But I know this. Based upon how I envision this whole process working, and Planck's constant, which is basically the Planck's, there's like Planck's energy constant, which is like the smallest bit of energy you can have, and this was calculated using from the black body radiation numbers and stuff like this, experiments. Okay. And then there's Planck's length, the smallest bit length that you can have occupied by energy, allegedly, something like along these lines, right? So, using Planck's constant, I divided that, I divided that into the size of the electron, the Planck's length, and what I came up with was roughly about, I don't know, depending on whether you want to do it when the electron is in its larger cloudish form, like 10 to the minus 18th, or whether it's in its very small particle form, like 10 to the minus 22nd. You get different answers, but roughly what you're looking at is in the ballpark of about a trillion. Okay? So you're looking at a size difference of about a trillion electrotons, or you could argue gravotons, will make up one up quark, or if it's electrotons, they'll make up one electron. Okay? So you're looking about a trillion difference. Okay? So if we can measure an electron, if we can just get a trillion times more precise, we might be able to measure the actual electrotons that are making up the field, according to my prediction of what is going on here and how everything fits together and is all copacetic. Okay? So it's very small. A trillion to one is very, very small. Okay? Think of like me, and then like a minute piece of like fine like powdered sugar, like one piece of powdered sugar next to me, and even that would probably still be off by magnitudes of orders. Okay? Very, very small. Okay? So, shift this orientation, blah, 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 conductors, get kicked. Okay, now we're still explaining the right-hand rule. Here's got Hund's rule. Here we go. Fine structure interaction is what that's called. The spinning of the nucleus, which creates a field around the entire atom, essentially, that interacts and makes the electrons spin in a certain direction, is called the fine structure interaction. Just so you know. I'm not making this up. This is all real stuff. Okay? I will tell you when I'm interjecting my opinion into what this. Okay? Oh, man, stupid. Okay. All right. So, here we are explaining the right-hand rule. Okay? So electron outspin states, current classical physics, downspin for testing mainly particles in a vacuum. Okay. So here's something I want you to think about, okay? Here's a thought experiment. You got two wires, two conductors, right? And you're running electricity by them. And the magnetic field around these wires completely flips orientation by nothing else than the direction in which the electrons are flowing. Okay? Whatever direction the electrons are flowing, you have the right-hand curl rule around it. If you're a clever man, this is all the evidence you need to know that when only the direction is changed, force also becomes opposite, meaning that the only possible difference between the two fields and how they're generated is chiral in nature, basically like spin. Okay? So spin is chiral. You can spin this way or spin that way. Okay? That's what it means. Same thing depending on the orientation. Same thing. Okay? Now, if you're a clever man, this is all the evidence you need to know that I'm right. Because there's zero ways to explain this, except for the way I'm explaining it. That's why I'm pretty sure I'm right. Okay? Now, electrons want to travel the speed of light when they're in cloud form, but they get slowed down when they interact with stuff, blah, blah, blah. Conductor is forced to point orbitals, blah, blah, blah. Electric field, they thought it was a liquid of sorts, okay? This is important. When you start thinking of the electric field as a fluid, a liquid, like many other things in this world, like air, all of a sudden, things start making sense and popping off, okay? So, having a field or a liquid, when you travel through that liquid too fast, what happens? Compression wave builds up in the front, and it's called a shock wave. And the shock wave is perpendicular to the force of the object, as a magnetic field is perpendicular to the force of the object. That's all a magnetic field is a shock wave of the electric field. That's it. That's all it is. It's just a shock wave of the electric field. And what is the electric field made up of? Trillions and trillions and quintillions of electrons that are being shot out in all directions. And because it's just a small particle being shot out in a specific direction, it adheres to the R squared fall-off rule, which we know the electric field and gravitational field both share. Meaning it's the same thing that's going on there. Same process. Not the same particle, same process. Okay? It all works. It's all copacetic. Okay? Okay. Now we know the virtual photons can carry angular momentum, which is good because I'm saying that gravitons and electrotons are what is currently regarded as virtual photons, and we know they can carry angular momentum, which is good because they have to for my methodology to work. So it works, okay? Now we're just going in. The reason why they have a boundary layer is because we know they have angular momentum, and this gives them Pauli's exclusion principle, blah, blah, blah. I mean, they just have a boundary they don't want to cross. They don't want to mix together. Okay. I feel a shockwave compression, blah, 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 sideways perpendicular. Pretty much explained a lot of this in my last episode a month ago on a lot of this stuff. Just feel like it means okay. Now, here's one thing, okay? So we know that gravitons and electrotons also travel at the speed of light as photons do, and electrons want to when they're not being finagled or interacted or messed with at all, okay? If you just let an electron go in the vacuum of space, it's going to go the speed of light. Believe it. Up quark too. Any simplistic particle vortex is going to want to do that if it's going to be able to. Yeah, so in Maxwell's equations, where you calculate it, blah, 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 the interaction play between the magnetic and electric force comes out to be the speed of light. That's going on. It's the same thing for the gravimetric and gravitational field interactions. Exact same process, it's just a different particle, but it's the exact same thing that's going on, okay? So, we have a field, a particle spitting out this field of electrons, say electrotons, spitting out left and right? And now we have an electron that's traveling through this field of electrotons that's already there. It's an electric field. It's making its own electric field. It's just a bunch of electrotons are there. And this electron or electrons are traveling, and they want to go the speed of light, but they can't, but they're going as fast as they can until something stops them. This puts force on whatever's in front of them, which is the electrotons, the electric field itself, which is slowing them down. And that's what creates the shock wave, the perpendicular force, okay? Now, because electrotons and gravitons are going to travel the speed of light, unless their generation process is instant, which it probably is not, they're going to be oblonged, okay? They're going to have length to them, more length than width, like a photon. Photons are long and skinny, okay? Because they're a failed vortex that happened over time. Where an electron, instant. Or an up quark, instant, okay? But an electroton, remember, and gravitons are like a half-breed in between photons and an electron, okay? So they are going to be oblonged, okay? And this is good because when they're compressed, this is going to put force on them to change the direction of their force to comply with whatever's energetically, more lowest state of energy, right? And so they're going to be forced to shift their momentum, which is good because that's what we know is happening. It's all fitting together slowly but surely. We're getting there, okay? Okay. Now, using electrokinetic motion to create forces, repulsive force. Okay. So, now, how is force actually generated with electrotons and gravitons? Okay. We're just going to go into electrotons. It's the same thing for gravitons. Okay. But just know that it's the same thing, but I'm just going to focus on electrotons so we don't get too lost in the sauce of it all. Okay. So, we have two different fields that are generating two different types of forces that we have to explain. Okay? We've got the electric field made up of electrotons, and then we have the magnetic field, which is also made up of electrotons, but they're just shifted and perpendicular in nature. Okay? So, electrotons adhere to Pauli's exclusion principle, meaning they don't want to merge the things. They want to bounce off things when they hit them. Okay? So, you have trillions of electrotons just being generated continuously, shot out in all directions from an electron. Okay? They're going to go straight until they hit something. If it is another electric entity that they cannot merge or annihilate with, they're just going to bounce off it and transfer the momentum energy to that. Okay? So this is how you get the repulsion force in a electric field. You have two negatively charged parts, two electrons, okay, and they want to push away from each other. Because they are both emitting the fields of electrons. They're just bouncing off of them and transferring that kinetic motion into force, slowly but surely. Remember, we're talking about trillions of electrons in play, and any electric field around an electron at any given point in time and space and time. Okay, we're talking a lot, and it's going to take a lot to hit them. Okay, it's going to, if they're 1/trillionth of the size of the electron, it's probably going to take about 1 trillion hits before that electron has enough force as if the electron just hit it itself. It's not going to be instant, but it is going to be force 100% that is going to eventually win today. All right. So that's how we get repulsion in an electric field. It's very simple. Just shooting bullets at things. Blah, blah, blah. And as you shoot someone, they're just slowly getting hammered back, bullet by bullet. That's what's going on with the repulsion factor. Very simplistic. Our brains can understand this, okay? Now, the attraction is where things get a little funky. Not because our brain can't comprehend it, but okay, our brain can't comprehend exactly what's going on, but it is what it is, okay? So, we have an electroton, okay? And now we have another particle, like let's say a positron, okay? They're opposite charges, which means they're going to attract, not repel, okay? So now, both particles are emitting electrons. The electron is emitting electrons, and the positron is emitting anti-electrons. Okay? They're not the same. They're the exact counter opposite as far as polarity goes and vorticity. Okay? So, when they hit, when the electron and the anti-electron hit, they immediately annihilate. Cancel out into nothingness. I don't know if this is some sort of energy transfer that's released, like photonic, only it's very small. We have no clue it's there. Very possible. I have no clue what's going on with that energy. All I know is that they annihilate upon contact. If it's a positron and an electron, their two electrons together will annihilate. Okay? Now, if the electron of the electron hits the positron, it's also going to annihilate. It's going to annihilate that electron, and it's going to annihilate a sliver, a trillionth of that positron. Okay? You have exact opposite charges, okay? And when they hit, what they do is they annihilate. And that annihilation creates an implosion, not an explosion. An explosion, things explode out. An implosion, things implode inward. Think like a submarine imploding under the pressure of the ocean. Went too deep. Crunch. Okay? It's not going out in space. It's not pitting force outward. It's drawing force inward. Okay? So you have an electron that is annihilating itself upon, that part of the positron. It's going to create an implosion. And that implosion has a pulling force on the positron. It's only 1/trillionth of its weight. But keep in mind, trillions of these things are in play at any given time. It's only a matter of time. And by time, I mean like a millisecond. Before 1 trillion of those bad boys are going to hit and annihilate against the positron enough force to pull it. And the positron has its own anti-electrons that it's generating constantly through its vorticity cycle that are going to be doing the exact same thing on the electron. Okay? Now, when you have an up quark, and an electron, it's the same reaction as far as the field reaction goes anyways, okay? The gravitational field and the electrical field. They interact and they annihilate each other. at least the electroton will annihilate on the up quark, and the up quark's graviton will annihilate on the electron, meaning that they also will have that attractive force that we know as gravity, that pulling them towards each other. But there's a slight difference. Remember what I told you now. The up quark and the electron are not simply just counter charges. They're completely different energy signatures, and they cannot annihilate and cancel out. So even though I don't understand this yet, because I don't understand the exact difference between the vorticity of the electroton versus the electron versus the photon. That's where I'm at. That's where I'm stuck at right now. How exactly are these vorticities different? They're very close, but they're different. So, for whatever reason, the electroton will annihilate on the up quark as though it were a positron. But when the electron and the up quark touch, they cannot annihilate. They cannot make the same energy photons. It won't happen. So then you get, they stick together, and then that's what we know a proton is 3 up quarks and 1 electron, and the 3 up quarks are just constantly fighting over the retention of that 1 electron, okay, because it won't annihilate, but it's right there, and so they just keep trying to pull it closer and closer. That's what's going on. All right, now. With a magnetic field, that explains the attraction with an electric field or a gravitational field. That's what's going on. That's the attraction. That's how it's generated, or the repulsion. Okay? Now, for the magnetic field or a gravnetic field, it's a different beast. Okay? It is a different beast. What you have is the magnetic field loves to interact with other magnetic fields. Not so much electric fields, but it loves to interact with other magnetic fields, okay? So, let's say we've got a bar magnet, okay? Electric magnet could be the same thing, but let's just go with a bar magnet for right now, just to, sum it all up, okay? A bar magnet is like a bar, right? Like this. And let's say the magnetic field is coming out the north here and going into south. And it really is. These really are field lines. I've come to realize this. It really is electrons that are traveling from this north field around in a circle and curl of the field to the south. Okay? And the electrons inside of the magnet are spinning in this direction, okay? Not like this, like this, okay? That's the direction they're spinning, and that's what's creating the magnetic field to go around like this, the electrons. These electrons are spinning in their curl. The way that works, it makes the whole thing spin this way, and the field goes around like this, okay? That's how it works, okay? Now, how do 2 magnets repel each other or attract each other? What the fuck is going on with that? Okay. For the repulsion, it's the same. You have 2 magnets, right? And they're both pitting fields out against each other, okay? You have 2 like fields, okay? You have a north field and a north field, and they're both spitting out the electrons, spitting them, just shitting them out like a diarrhea. Okay? Those electrons are going to compress together. Because remember, the shock wave, the magnetic field, is already the electric field compressed. That's why it's there. The electric field is being compressed, and that's what's generating the magnetic field, the shock wave. Okay? So, you're going to have two fields that are spitting out electrons at each other, bouncing off each other, and perpendicular in nature. That's why when you push two magnets together, it feels like there's actually something in between them that's invisible, that's stopping them from coming together. There is. It's the electrons. They're being compressed. You're trying to compress an incompressible Pauli exclusion object. It doesn't work. You can put in the force to displace the field if you're strong enough, or if you can overpower the magnet, depending on how strong the magnet is. But that's what's going on. The electrons are shooting and they're bouncing. They're bouncing off the electrical parts, the negative parts of the other magnet, pushing it away, and the actual fields each other are compressing doubly against each other, creating even more force pushing away. Okay. Think of two water jets being shot, two fire hydrants, two firemen with fire hoses shooting each other with fire hoses. They're just gonna push each other back further and further away. That's what's going on. Okay. For the repulsion. For the attraction, it's a little different. It's still good to think of terms of a fluid like water. Okay. For the attraction, what we have going on with magnets, with two magnets attracting each other. Okay? Say here are two magnets, okay? Here's our two, north and north, okay? Two north poles, all right? Can't put them together because they're like two fire hydrants, two firemen with hoses shooting each other. But if you flip one, now what do you got? You got this dude is shooting out water, and this dude is sucking in water. Yeah, he's shooting out this direction, but it's coming around, it's getting sucked in this way. So you're shooting out water that's getting sucked in. Have you ever been in the ocean and got hit by a riptide, and that water just swirled around you and just sucked you out to the sea, and you get pulled like 20 feet in deep water, and you're like, what the fuck was that? That was a riptide. The water fucking did a swirly motion and then sucked back out, and you went out with that water. That's the attraction process. Okay? The electrons are working with each other to where they want to have the lowest energetic state, which is, instead of this one going outward and spinning around and this one coming and sucking back in, they just want to combine. This one wants to shoot out and this one wants to suck it all in, okay? And then the field is also going around hitting, the field is also going around and hitting parts of this magnet, pulling it even closer, and this magnet is hitting and pulling this one even closer. So you got two things. You got the electrons want to act as a single stream going through a single magnet because it's less energy, less energetic, and the universe is lazy, as I always say. And then you also have the field lines, which are coming back around, and hitting this bad boy in the ass, pushing it into it as well. It's a double whammy, okay? That's how magnets work. That's why magnets only work with other magnets, man. If you pit like things like iron filings and a magnetic field, the only reason why those iron files add up to the poles and create the field lines is because the field lines are magnetizing the iron filings, and they're making them little magnets that are reacting according to how the field lines tell them to react. It's all what it is, man. But there's something very interesting about the magnet you need to know. I told you that field lines are real. Okay? You really do have a virtual compressed layers of electrotons being spit out the North Pole and curling back around through the curl of the magnetic field into the South Pole. What I didn't tell you is that the electroton does not just die and give up at that point. You're like, well, I made my journey one trip and I'm good. I'm dead. No. It's a positive feedback loop dynamo. Okay? Meaning that when the electroton goes around, it keeps going. It goes through the magnet as the magnet wants it to, and it keeps making more and more cycles. It's an infinite feedback loop that ends up making the magnet way more powerful than it ought to be. This is why magnets seem to be magical, supernatural things of, magical orientation. They can defy anything. Gravity, pull up gravity, and it's just like, hey, here's some magnets right here, man. Yeah, man. Look at this. Defeat magnet, defeat gravity, man. With these, that's how powerful they are. It's not because the electrotons are normally that strong. It's because it is a positive feedback dynamo loop where the electrotons are going around, and when they go around, they are making the electrons spin from the right-hand rule even more, so that it makes them go even faster. And it just keeps going and going until it reaches its peak form, depending on how many domains in the magnet are aligned and are going in the same direction, dependent on the strength on how much the feedback loop can take effect. Okay? That's why magnets are so fucking powerful. It's actually an insane feedback loop on itself, and it's impressive. This is going to come back around. This is not the end we're going to hear of this, okay? There's something else that we're going to have to go into this, okay? But, yeah. Charged electron will hit the positively charged quark, both having opposite vorticity spin directions. So, there's another thing. I don't know why yet. It comes down to the actual vorticity process. But I do know this, that for whatever reason, vorticities of an opposite direction seem to be attracted to each other because of the way that they spit out their electrotons or gravitons, all right? Now, I taught you that the electrotons not only retain the same vorticity of their parent particle, but also the spin. How do I know this? I know this because there is also a positive feedback loop, a dynamo, going on in the particle itself. And this is only possible if the particle that it's made up of, the electrotons, say for an electron, also have spin like the electron does. Then what you can have is this loop, right? Let's see if I can. Okay. So you got this particle, right? And it's spinning around in its little vorticity loop, okay? And what that's doing is that is making the electrotons want to travel not only like this, but also it's going to hit the core of this bad boy, is going to have its own circular loop holding the tori, the vortex, together. Okay? That's why the particle wants to be together, is because of its vorticity. It's spinning around to make it complete. because these electrons that are spinning also have spin, which means when they hit things, they transfer that spin. And that spin sends everything in a certain motion. Okay? Now, how do I know this? I know this because every time this vorticity cycle it does one cycle, one crash in, like the electrons go and crash into each other. Some being in the magnetic form where they're shifted, some being in the electric form where they're not. What has to happen is we have to have a process where we can make more vortexes, more electrons. And we can only do that if we have excessive energy. Otherwise, what I'm saying is impossible. What I'm saying is impossible to have any particle that emits a field of tiny particles around it constantly, unless this particle is getting consumed and cannibalized by this process and withering away until it eventually shrivels up into nothingness and ceases to exist. It's the only way it's possible. But we know this does not happen. We know the fields that are being emitted continuously from all particles does not deteriorate the particle itself. So there has to be some sort of domino process going on in the particle that's generating excessive energy that can somehow be converted into this secondary, vortexes, the electrons for an electron, they're going to be emitted. So every time you have a crashing down on this thing, you're going to have a bunch of electrons that are spitting out of the electron, right? And it's going to be, as the goes around 360, it's going to eventually spit out these electrons 360 all around. It's going to be chaotic, it's going to be random, it's not going to be, perfectly thing, but eventually the sum overall is going to kick in and you're going to have a true balance in all directions because it's a particle that's spinning constantly. And so as it spins, it's going to hit all directions eventually, as I predicted it would in my second paper many years ago now. Some more booze. More. Don't be stingy. More! You can't do physics unless you're lit, man. I'm telling you, bro. It's the way it is. It's just the way it is. All right. So, you got electrons in this electron. Some are in electric field form, some are in magnetic field form, okay? And they're doing this thing. And they're making the other ones do other things, okay? And what you have is like if we were to sever this and split it open, what it would resemble is the wire. Remember the wire, conductor of electricity being sent down it with the right-hand rule around it, okay? Now, if it's a positive entity like an up quark or a positron, it's the left-hand rule. It gets reversed, remember. But if it's electron negative, it gets the right-hand rule. Okay. Now, that's going to want to spin this faster, the center of it, which is going to tell these to spin faster for the vorticity. It's the exact same feedback loop mechanism in place as we have in a magnet. And that's the reason why magnets have such excessive power. Like, I can take these magnets, right? And look at this. This magnet is pulling against gravity. 9.8 meters per second gravity is pulling on this thing. But this magnet will hold this against the force of that 9.8 meters per second of gravity forever. Even though gravity is siphoning that much energy out of this magnet, it does not give a shit. because the positive feedback loop in this magnet is generating more energy than the gravity is pulling from it. Okay? And if I pull hard enough from it and drain more, then I can overpower the energy being made from the positive domino loop. But just know that this motherfucker can hold its own weight against gravity forever. Infinity. Okay? How the fuck can you have that much force being done if you don't have some sort of energy being constantly generated from this bad boy, like I claim in a positive feedback loop domino? Okay? It's the only way, man. It's the only way this shit works out. There's no other way to make it work out. This is the way. That's how I know it's right. So, we have all that energy in a magnet. We have also excessive energy in every particle because it is behaving very similar to the positive feedback loop of a magnet. So it also has buttloads of excessive energy to dole out to whatever it needs to do. And that tends, for whatever reasons, it manifests itself in smaller vortexes that we are going to call electrotons and gravitons, which make up all of the fields that we know of. Okay? Man, not sure if there's anything else here. I think I went through all of it. I think I did. I mean, there's a lot of things. If you want to read the paper, of course, it's going to be linked down below with my archive, all my other papers. But I have a lot of references here, like to the experiments, Skarmions. Experiment where they actually made EM vortexes. Like, if you doubt that it's even possible to make a vortex like I'm claiming particles are, you're wrong. Hold on, I'm looking at the wrong screen. You're looking at the wrong screen. It's my fault, though. Yeah. So, yeah. Rim. This is where I figured out which direction the vorticity goes. Well, like here, the experiment right here, man. The Wang experiment, where they made EM vortexes, and they behave just like I say. In fact, hold on. Let me see if I can find a better picture of this. See, now we can look here. This is a vortex that they made from this horn antenna, an electromagnetic vortex, just like I say electrons are. And look at it. Does it not look just like I fucking say? Here's the vorticity. It goes from inward outward, like, say it has to be. And you have this spinning of the right-hand curl rule that's holding the whole thing together inside of it. They can measure this. It's just like I said, man. Like, this is the way it is. Like, I get it. Like, a lot of people don't want to believe it because they've been lied to their whole lives, about string theory and general relativity and quantum mechanics and all these other BS theories that, their math seems good at first, and then when you start digging into it, nothing adds up. And it's all bullshit stacked on top of bullshit. It's all propped up, Okay. Models now electronic quark to annihilate by contact, blah blah blah. Yep, I think we already went over that. Don't even know what that is. Oh yeah, and then there's this effect called the Schwinger effect. Okay. This is important. This explains a lot. Maybe not that one. Maybe this one. Okay. Schwinger effect. Sure, that'll bring it up. Sure, that's what I meant to say. The Schwinger effect, also known as the Schwinger mechanism or vacuum pair production, is a phenomenon in quantum electrodynamics where an extremely strong electric field can spontaneously create matter and antimatter pairs directly out of the empty vacuum energy. It's not empty vacuum energy. You have a fucking strong field of way too many fucking electrons, and then some disturbance or aggregation in that field is creating your electron and positron pair. Okay? This is what I predicted years ago when I came with my gradual universe theory, and here it is. Bam, it was there the whole time, I just didn't know about it. But this is exactly what I've been saying, man. So this Schwinger effect, which has been measured, is real, is only possible if what I say, how the fields operate, is true. Know that. Otherwise, you're at magic with quantum mechanics and shit. You're just at a pixie flew by, farted, and the pixie dust of the fart magically materialized and made shit happen. That's where you're at without my fucking dynamic gravity. That's where you're at. Whether you know it or not, that's where you're at. My dynamic gravity, as you can see, is pretty fucking comprehensive at this point. Explained everything. So, yeah, I think that's everything. I think we did it. It only took an hour and 27 minutes. Not that bad. Hell, man, there's college courses at, 2-hour blocks, like an hour and 40 minutes, man, an hour and 45, hour and 50, man. I remember back in college, man, those classes were brutal. And I did it in less time. And I explained magnets, magnetic fields, how they all work, electric fields, gravitational fields, buddy. I explained the right-hand coral rule. I explained everything in this last hour and a half. And if you watched it all, God bless you. You're a physics sleuth or an inquisitive soul, and I love you all the same because you're fucking awesome. And if you didn't, well, you ain't dead yet. You still got time. All right. On that, adios, muchachos, and I'll catch you whenever I feel I got something worth saying. Adios.
Like, subscribe, submit.